Welcome to homework.
So we want to convert our cruising speed to feet per second. So if we have 90 miles per hour, we know that we can multiply that by the 1 hour over the 3,600 seconds. And then we multiply the 1 mile, and then on top is 5,280 feet. So now what we get is we're going 132 feet per second. So with that conversion, we want to do the minutes to seconds, so we know it's 15 minutes, and in seconds that's going to be 900 seconds. So with that, accelerating from rest, we have that A of t equals 4 feet per second squared. V of t is going to give us 4t plus c, but since v of 0 equals 0, we note that v of 0 will equal 0 plus c, so it's just going to be 0. So our v of t function is actually just 4t. Now we want to take the antiderivative again to get our s of t. Then that's going to give us 4 over 2, which is just 2. So 2t squared plus some other value, c2 we'll call it. It is at 0 when t equals 0. So that means that s of 0 equals c2, which equals 0. So our actual position function is just going to be 2t squared plus, actually just 2t squared. Then it's time to get our max cruising speed. So we get that 4t equals 132, because that was our feet per second. So that's t equals 33 seconds. Then putting that into our position function, s of 33, that tells us that the distance traveled is 2,178 feet. Then we multiply this time at cruising speed by the speed to get the remaining distance traveled. So that's going to be 900 seconds times our 132 feet per second, and that ends up giving us 118,800 feet. So the total distance traveled is going to be this value plus this value, and that's going to give us a final answer of 120,978 feet, which we will convert back into miles. So that's 22.9125 miles. All right. Now moving on to part B. We found some important values in part A. So now we want to determine the time traveled at cruising speed. So if we take the 900 seconds minus the 2 times 33, so that's the 2 coming from our other equation. So now what we have is we subtract this, and now we get 834 seconds. So the distance traveled when accelerating and decelerating is going to be 2 times 2178, which is going to give us 4,356 feet. If we multiply the time at cruising speed, now what we have is our 834 seconds times the 132 feet per second. That's going to give us 110,088 feet. So that means that the total distance traveled is going to be this value plus this value converted into miles, which is 21.675 miles. For part C, we use our previous information. We know that the total distance to travel is 270, if we take the 45 miles. So our total distance to travel for 45 miles is 237,600 feet. So at cruising speed, that's going to be the 237,600 37,600 minus the 4,356, which is the amount of time accelerating and decelerating. So that's 273,600. Actually, no, 233,244 feet. Then we use the equation for constant speed, which is time equals distance over speed. So the time that we end up getting is 1,767 seconds. Converting that into minutes, we know that is 30.55 minutes. Then we have one last part to do, part D. We know that the total time to travel, if the time required to accelerate and decelerate is 66, the train travels 4,356 feet. If we have 37.5 minutes, that is going to take 2,250 seconds. And then the cruising speed time would be 2250 minus 66, because that's our accelerating and decelerating time. So that's 2,184. Then using our equation for constant speed, we get distance equals the 132 feet per second times our 2,184 seconds. So that means our distance is going to be 288,288 feet. Convert that back into miles, and what we end up getting is 55.425 miles. That is our final answer for part D.